Okay, I call this big brain research. I mean, this is really stuff that just wrap your head around is really interesting. Researchers are making incredible breakthroughs with stem cell research. Just recently, they were able to grow a rat pancreas, heart and eyes in mice. And what this all means and how this all applies to human beings is what I'm going to talk to Dr. Jun Wu about of the Salk Institute. Nice to have you here. So you heard me introduce that. Trying to just explain to me quickly what your research is. Tell me what you're doing.
So the motivation and the ultimate goal of this research is to address the rising demands for organ donors. So there is a worldwide shortage of organ donors throughout the world, and in the United States alone, there's over 100,000 people on the waiting list waiting for organ to be available.
Like kidneys and eyes, everything, right? All kinds of organs.
Mostly kidney, livers, and pancreas. And
how can you possibly? I mean, I'm trying to wrap my head around how you can tell a stem cell to grow an organ. Tell me how that process works.
So stem cell has this potential to generate every single cells and organs and tissues in our body, but this potential hasn't been realized using a culture dish. So we don't fully understand how to turn a stem cell into organs, especially three-dimensional organs in the culture dish. But the animals and humans, we do it every day. From one single cell to a mouse can be generated within 19 days. So we're thinking, why not let the developing embryo from an animal to guide the human cells to turn into any specific tissues and organs that we may need for transplant.
So you would grow an organ in an animal and then transplant it to a human? Is that possible?
Exactly. We try to inject the human stem cell inside the developing embryo, so the embryo will guide the human cells and give the instruction for the human cells to become a specific organ.
Now, there's got to be all kinds of regulations, people saying, wait a minute, that sounds very weird. Tell me how that process works.
Exactly. We are very serious about how to deal with ethical concerns. Actually, before we can do the first experiment, we have to work with ethical committees to come up with a step-by-step approach. That's exactly why we stopped this research around 3 to 4 weeks into gestation, so that we can analyze how the human cells contribute and where do they go before we can develop better and safer strategies to prevent the human cell from go to some tissues that we don't want to.
Yeah. So do you anticipate that in the future, let's project 10 years down the road, 20 years down the road, you would have organ farms where you would be able to have people who need specific organs to be able to pick and choose what organs they need if there was a medical necessity for it?
I think that's one of the possibilities. The other possibility is actually we don't need the animal to be born. Some of the cells in the fetal stages actually perform better than the adult organs. So for example, the pancreatic beta cells, so the cells in the developing embryo actually are better for transplantation, and right now it's actually ongoing in the clinic. People isolate the islets, beta cells from the pancreas from fetal stages.
So you're able to do things with animals that it's illegal to do with humans?
Yes.
Very interesting. So you've been doing this for how long at Salk?
I've been working on this for 4 years.
Oh, fantastic. Well, thank you so much. Very interesting research, and we'll look forward to what kind of results you get. Dr. Wu, thanks so much. Nice to have you here with us on Good Morning San Diego.
Thank you for having me here.